Here's another example to illustrate that derivatives are easy, but integrals are hard. Let's take a look at this example. Integral of x plus 8 over x squared minus 2x plus 10. In first looking at it, let's see if the natural log form works with this one. So if we think of the u being x squared minus 2x plus 10, the proper du would be 2x minus 2 dx. So it looks like we're close, that at least we have the x. So if we were to multiply that by 2, we could at least have the 2x. So it would have been nice if it was x minus 1, but it's not. It's x plus 8. So let's do this. Why don't we go ahead and split this up into two separate integrals. Let's split this up into x minus 1 over x squared minus 2x plus 10 plus integral of, well, minus 1, we could make that 9. So that would be equivalent to x plus 8 over x squared minus 2x plus 10, both with dx. And so with this first integral, what we can do is multiply that by 2 and compensate with 1/2. 2 times x minus 1 dx over x squared minus 2x plus 10. And then we actually have a natural log form where we would have the u being x squared minus 2x plus 10 and the du being 2x minus 2. So the first integral becomes 1/2 natural log of the absolute value of x squared minus 2x plus 10. But we have this other integral right here. We have this other integral, and I'm going to go ahead and do that on the right-hand side. So that's going to be the integral of the first portion that we split up. And let's go ahead and see what we get for the second portion. For 9 over x squared minus 2x plus 10. Now that's definitely not a natural log form because we don't have the possibility of creating the proper derivative of the bottom on the top. However, maybe there's something else we can do. Maybe what we can do is we could complete a square. X squared minus 2x plus 1 would complete the square. And then consider that we would have a plus 9 in order for that to be plus 10. And so we can rewrite that as, we'll write the 9 on the outside. We have 1 over x minus 1 squared plus 9 dx. Now if we go ahead and factor out the 9 from the bottom, we're going to have 9 over 9, which will be 1. And we have 1, and we're dividing everything on the bottom by 9. So I'm going to write that as x minus 1 over 3, because divided by 9, that's actually 3 squared, plus 1 dx. So it looks like we have the possibility of the arctangent form. Now, of course, we have to readjust it, because if u is equal to x minus 1 over 3, then the proper du would have to be 1/3 dx. We have to have the proper du also in there to complete the proper arctangent form. And note that that right there is 1. So we have 1 over x minus 1 over 3 squared plus 1 dx. And remember that you can always multiply by a constant in order to get the proper du. And so what we're going to do is we're going to go ahead and multiply by 1/3 and compensate with multiplying by a 3 outside, which you could always do. And so this ends up being the arctangent form. We have plus 3 arctangent of x minus 1 over 3. And of course, for any integral, we have plus c. And so this entire form here, 1/2 natural log of x squared minus 2 plus 10 plus 3 arctangent of x minus 1 over 3 plus c is the entire integral of x plus 8 over x squared minus 2x plus 10 dx.